Thank you very much. Yeah, I'll talk about the lessons that we've learned from using bleeding edge technology building our startup. Yeah, so my name is Viktor Eriksson. I'm the CTO at Pilloxa, and we're a medtech IoT startup based in Stockholm. We help people take their medications. And I've been working professionally with JavaScript and ClojureScript and some other technologies that I'll mention for about 5 years. And yeah, as the introduction said, I enjoy these other little emojis as well. And yeah, so what I'll talk about then today. First, I'll talk a little about the allure of the bleeding edge. Why do we want to adopt a new technology at all? And then I'll talk a little about what we at Pilloxa needed and the tech stack that we chose, pros and cons with that tech stack. And then I'll try to generalize these in some sort of learnings that you might or might not agree with. So, to begin, the allure of the bleeding edge. Obviously, it's apart from feeling very cool and exciting to do something new, it's also historically proven to yield very good improvements in productivity, quality, and performance. So it's definitely worth pursuing. It's not always a success story, though. When I started programming, or as a front-end developer, 2013, this framework was pretty cool, famous. I don't know if you've heard about it. I was a new beginner programmer, and when I read the ultimate web platform for developers and designers, I thought, this is obviously for me. The problem was, the selling point was the 3D renderings are so good that it will make native mobile apps obsolete. And you can use it even as a beginner. I used it as a beginner, and it resulted in a horribly laggy parallax website. And I tried to optimize JavaScript in ways that you shouldn't optimize JavaScript. Not successful at all. Then, however, I tried the next framework that also came out in 2013. And this is the React website from then. And it has a much more humble tagline, a JavaScript library for building web user interfaces. And what React promised was, you only edit the global or component state, and we will solve the DOM for you. And yes, I had written some previous web apps, and this resulted in way less bugs and pretty performant, even when written by a beginner. So you can see, bleeding edge can be very good and very bad. Back to Pilloxa. So we are a medtech startup. We have a smart pill box with sensors that sense if you take your medication or not. And if you're about to be late or miss your medicine, you get a notification in your phone. So I have a smart pill box and an app. I'll be talking mainly about the app side here today. We started in 2015. And as you'll see, most of the technologies that we use are from that year or a couple of years earlier. So there's a lot of new technology. What we needed was an iOS and an Android app. We needed some sort of cloud backup and sync so that when you get a new device, your data will still be there. And then we needed some analytics infrastructure to keep track of what our users are doing, or are they using the app, those kinds of things. Anonymized, of course. We're very, very adamant about security. So, the actual technology that we use. In the app, we're using, you can't see it right now, but it's React Native, and we're using ClojureScript to compile to JavaScript in the React Native app. And then, in the cloud backup and sync, we're using AWS, but we're using Terraform to manage AWS. And we're using Clojure, and we're using Postgres as our database. And then for our logging, which is anonymized on the client side, we're using the Serverless framework, previously JAWS, and Elasticsearch, and some Firebase. So now I'm going to talk about our experiences with these technologies, and it's very important that this is from our perspective. You might have totally different experiences. So we used Firebase to begin with for our app logs and bug reports and those kinds of things. And it's good because it's extremely easy. For those of you who don't know what Firebase is, it's like MongoDB as a service, you could say. And it started 2012, and it's super easy. You can just post a JSON document to an endpoint, and that gets inserted to a database magically. And it's also, we used it for some hardware. We were developing some hardware tooling to test our hardware, and then we had one server that was collecting metrics from the hardware, and another that we were displaying some charts of how these metrics came in real time. And it was super easy to set up. You magically just subscribe to some data, and you get it, and it works very well. We had some problems though when in the production when we started filling up our web app with logs. We realized the web UI couldn't handle the amount of data anymore. I was like, okay, it's fine. It's a web UI. I'll just delete the logs from the CLI. But I couldn't do that either. It also timed out. So in the end, I had to fetch all the keys and then delete them, do a script that iterate through all the keys and delete them one by one, which is something that obviously you don't read that on the website. And it also had, for us, very limited query possibilities. So that's also something I could have researched, but I didn't. Yeah, React Native. We already heard some talks about React Native today. And the main selling point, I guess, is to write multi-platform apps in JavaScript with high productivity and better performance than HTML5 apps. And the good things for us, designing a UI with hot code reloading is super awesome compared to normal native development when you have to recompile and that kind of stuff. So that's been really nice. And also, since we're using ClojureScript, we can have the REPL connected, which is then we interactively connect to the running app, and we can execute commands and show notifications and modify text and stuff. We can control our whole business logic with basically zero overhead. So the feedback loop is super fast. Also, I did some calculations. We are sharing 85% of our code between platforms. So then the rest, 50% is Java plus Objective-C. Another good thing about React Native is that you can leverage all these compiled to JavaScript languages. Not all. You can, Elm, unfortunately, has its own, doesn't use React. But the ones that use React, TypeScript, Flow, Reason, ClojureScript, you can use. Another good thing is with native code, it might not be super performant, but the interop is very easy. So we wrote a lot of interop code, and it's very easy with native. And a good thing is also the vast NPM library, or all the NPM libraries that you can have access to. Some problems that we've found working with React Native is it's kind of running fast and break things. There's still breaking changes in React Native, especially on the tooling side, which affects us using ClojureScript. It has naturally some slower performance than native, which most notably is noticed when you open the app. It takes quite a while to load up the actual content. And we had to rewrite some Bluetooth things in native. But we still would have had to written those in native, though, so that's not really a loss. And also, obviously, Aqsa is also NPM with all the security problems. And you are aware of that, I'm sure. Another technology we're using, Elasticsearch. So we gather all the app logs, and then we put them in Elasticsearch, which is a database that you can search. And it comes with a front end called Kibana. So you can super easily search through millions of logs easily. You can just spray all your app logs into there, and it just eats it. Very good. And it's easy to get going. And you can do just the basic easy search, like search for a word. But then when you want to do more advanced stuff, like how many times, aggregations, those kinds of styles, it has this fairly confusing but powerful query API. So a query is a JSON object, basically. The bad things about Elasticsearch that we run into is that when you're a beginner setting it up, you might not know all the settings that you want, and then you can't change those settings afterwards. Like then you're stuck with that. You have to like copy things up. So it's like a little bad. And it's also a new mental model. If I know SQL, it doesn't help me at all when I'm like doing these queries. You have to learn this whole new query language, or like query setup, I guess. And it's not super intuitive, and the documentation is not great and stuff. It is powerful though, but it can also be hard to debug when things are not working. It's not super easy to know why. We're also using ClojureScript. And ClojureScript, for those who don't know, is a functional Lisp that has immutable data structures, and it compiles to JavaScript. And the good thing about ClojureScript is it's a very powerful functional language. And I like functional programming, so then that suits me very well. It also has these really good immutable data structures built in. Nowadays, you have things like immutable JS, that is very similar. But the good thing is in Clojure, they're first-class citizens. You don't have to change anything. That's out of the box. It has a REPL, so you can, as I said, you can connect to your running environment and execute code. Which, if you haven't used that, you might not get how useful that is. But it's very nice. And it also has a very stable ecosystem. Although it might be a little fragmented at times, but basically, since the first time I wrote ClojureScript 5 years ago, not much has happened. And that's a good thing. Like I can use basically the same libraries. I rarely have to update them. It just works. So that's my personal experience. It's been nice that like no breaking changes. Those things are very, very stable. And it's also a dynamic language like JavaScript. And so a JavaScript function is a ClojureScript function, vice versa. And you have different data structures, but you can still access JavaScript data structures very easily. So the interop with JavaScript is very, very straightforward. Bad things is when you start off, I don't know if you've seen ClojureScript, but it's a Lisp. So you have all these parentheses and immutability and all these. And now immutability is becoming more standard with immutability JS and those things. But when I started, like I'd never heard of it before. So it took a while to get started and get my brains around it. It also has a small community, so if you run into a slightly edge case issue, then you can't count on someone from Facebook or Google to come and fix that for you. You have to do that yourself, usually. And also the tooling that, like now we're using ClojureScript and then React Native, and that can be a little complex at times. You can't be afraid to read some source code. And we're using Clojure on the back end. It's like ClojureScript, but for the JVM. Clojure came out 2009. And we share the specs. So Clojure and ClojureScript has these like runtime types that you can share between the backend and front end. So you can make sure that the same data leaves the front end and reaches the backend. And for us, Clojure has worked very well. We have a very basic REST API. We deployed it in a week, and we haven't touched it since. It works well. And I added another endpoint in literally 30 minutes, and it was deployed, and it works well. So for us, it's been very good. Then we're using Postgres, and this is the oldest technology in the game. It's from '96, very old. Obviously Postgres, super battle tested. Everyone uses it. SQL is powerful, but you can also use it as a beginner. And it works with all the tools. Everything is Postgres compatible. The problem is SQL. You have to learn SQL, obviously. It's not like you might understand it, but it's not super easy. And also when you try to do more complex analytics, you can do everything in SQL. It's just going to be this long code that no one understands. There's no variables, and it's just like, it's not super easy to work with analytics in Postgres, in my opinion. You couldn't have an ETL workflow when you take it up and you transform it and you put it back, or materialize views or things like that. But it's not ideal for complex analytics in that sense. They're using Terraform, and Terraform is a platform to, or like a tool to manage your AWS infrastructure as code. And it came out 2014. And basically, you define your whole AWS stack in data. And the good thing is it's deterministic, so you can, in theory, you can open a new AWS account, and you can just run Terraform. It'll deploy the exact same stack for you, apart from the data in there, of course, in databases and stuff. And you can version control it. You can use variables, and yeah, it's very good. Problems that we run into is, like, obviously in the beginning you have to understand what this is and how it works, and like you don't want to mess up your infrastructure accidentally, like, oh, I just deleted a database, whoops. Those things, like, so it's like that being tough to learn, combined with that it's a little scary. And then we're also using serverless for our debug logs. So we send the data to serverless that then puts it in Elasticsearch when it's been authenticated, etc. Good thing about serverless, super easy to get started. npm install, invoke, deploy, like very easy. And like no maintenance, you know, you have no servers running, that kind of stuff. And you also have API gateway, which is in front of serverless. Oh yeah, I should explain what serverless is. It's basically you can run, it's a tool for running AWS Lambda functions and with friends, Azure and Google functions in the cloud. So it's basically just like the tooling around it to deploy these functions. And it comes with the API gateway, which means that you get an HTTPS endpoint by default, and it's all like sorted out, and you load balancing, all those things are covered for you. The problems we've had with serverless, since it came out the same year that we started using it, it's been some breaking changes there as well. And it has like the CI, in my opinion, the CI story is not clear, and it's like, there's no way to know which version of a function that I deployed. So it's very easy to like, oh, did I deploy a new version of a function now? Or like what's happening? That might be a little difficult. And it's also limited environments. Like you can, or like supported environments is Node 8, for example. And so if you want to use Node 10, you can like hack around it with binaries and stuff. But like typically it's, yeah, you're out of luck. And also API gateway is also a problem, because we had an issue when our pillbox has a mobile, it connects to the mobile networks and sends data, and it doesn't, that mobile chip doesn't use SNI for its HTTPS, and API gateway enforces SNI, so then we couldn't send data to API gateway. API gateway would just reject our calls, so that's unfortunate. So now, like trying to sum this up, it's a lot of information. But the things that we've seen here is that things that are easy to get going with are usually more limited in their use cases. They can be extremely powerful if you hit their, like what they were designed for. But the problem is they all have like flashy websites, and they're like, they might be a software as a service, etc. And they will generally not tell you what they suck at. So like just, yeah. And other things that require more upfront mental, the first time you look at it, it's like, huh, what am I using this for? They can give you more control, and which means that you can use that tool for longer and for more things. And this is programming languages, naturally. Infrastructure things. They generally don't have sexy websites, or like bad documentation at least. And they're typically open source. So I've taken these technologies that we've had, and I plotted them on this scatter chart. We have intuitive and easy versus control. This is very arbitrary, by the way. Versatile and scales well, and that is not scaling as in performance, but it's more scaling as like, I can use this for a lot of other things, and when I learn more about it, I can use it for even, yeah, it'll serve a lot of use cases. Or versus you have specific use cases. And in our experience, this is how the technology plays out. Firebase, super intuitive and easy, very specific. Serverless, also very intuitive and easy, less specific. React Native, also not as intuitive and easy, but still quite specific, because you can't do a game in React Native. That's not very smart. You can do some games, of course, but like not high. And then we have Elasticsearch, which is interesting. Like you can, I've like faded it because it's in two places at the same time. So what it is that you can get started easily, and like it's intuitive and it works. But when you put the time in to learn their query thing, then it can also give you more control, and you can use it for more things. So it has like both. This is what I like when it has both things. You can get started easily, but it has like the underlying model that scales well as your problem space becomes more complicated. Terraform, it's like you can use it for all the infrastructure, and it gives you a fair amount of control, but there's also a lot of magic happening there. Postgres is the oldest contender. I guess it's the only one on that side. You can use it for a lot of things, but it's also fairly easy to set up. And if you're using a hosted version of Postgres, you don't have too many parameters to tune. It's like you don't have that much control, which I wouldn't want control over Postgres anyway, because it's complicated. And then you have a ClojureScript. Obviously, a programming language is Turing complete, so it gives you like a lot of control, and you can use it for a lot of things. So the takeaways. If you have like intuitive and easy new tech, you can get like extreme multiples of productivity. It's a lot faster to develop, for me, to develop only one code base with like iOS and Java with React Native than there would have been otherwise. But beware of their limitations, though. They're usually almost impossible to mitigate when you run into, API gateway doesn't support it requires SNI. There's no config that you can like, I just want to change this, or there's no open source pull request that I can do to API gateway. Just that it works how it works. And also, sometimes it could be worth spending some time learning something that seems a little complex, but they might be written by somebody who knows this problem space very well, and they have like figured out a very smart way of handling it. So even though it doesn't make sense to you in the beginning, it might make sense after a while, and then you might use that for a lot of things. And also another thing that I've learned over the years is, do not trust the cool promotional video of Famous, but trust the people that actually use the tool, because they are like the real users are the ones that you should listen to. They usually have the most relevant feedback. Yeah, I think that's it. Thank you very much for your time.
Thank you very much, Viktor. All right.
Thank you.
Got a couple of questions for you. Postgres is a NoSQL/JSON database versus traditional columns. Good idea or bad?
Yeah, you can definitely use Postgres that way, but I think we didn't in the end. Elasticsearch plus S3 covered our use cases in a better way. Like Elasticsearch is also NoSQL in that sense. So. But yeah, you can totally use Postgres that way as well. I don't know how the support is though for not all libraries work super well with the JSON part.
All right, next question. GraphQL, good or bad with that problem? What about gRPC?
Okay, yeah, I haven't deployed any GraphQL apps, but I do think that is one of those things that like a lot of people might be resistant to, because it's like, I don't really understand this is complex and new. But if you actually understand it, I think it could solve a problem very well. Like this whole idea of like not having to do a lot of requests and that you can do, for example, that you can update the front end without having to synchronize with the API is like, I think it's come of a real need. With N+1, I don't understand that part of the question though.
We're in the same boat, buddy. All right, next question. After knowing all the pros and cons, would your tech stack look the same if you would have to make the decision again?
Yeah, it's a very good question. What has changed since we started is that vanilla JavaScript is nicer, and a lot of the things I liked about ClojureScript, like destructuring and immutability, have reached vanilla JavaScript. It still takes equally long though to compile like Babel as ClojureScript, so I think I might have gone with the same. Actually, I might have possibly tried something typed.
Right. Could you elaborate on the kind of use cases you had to move back to native?
Yeah, so it's like mostly it's about Bluetooth. So our app works with Bluetooth in the background, and so instead of the React Native, as I said, it takes a while to start up the environment, and both Android and iOS don't let you do stuff in the background very long. They will kill your app. So we had to like move all the Bluetooth connection and reading to the actual native layer, because then it would be instant. And then when React Native woke up, then you can get the data from SQLite that we just saved we cached sort of the Bluetooth happenings in there.
All right. If Flutter resolves your cons of React Native, would you consider switching? If not, why?
Yeah, Flutter is super interesting, but I'm a little hesitant to. It doesn't feel like it has a community yet, and it feels like it's. I'm a little hesitant. It needs some time to get proven and people start actually using it. But it's a very interesting idea, for sure. But I'm not sure I love Dart either. So yeah.
All right. How big was or is your app? It's a personal question from Patrick.
I think it's. Yeah, I think it's only. Is it 30,000 lines of code or something like that? Yeah.
All right, from Chris, if you could snap your fingers and have a big team of native mobile devs, would you still prefer React Native?
Yeah, no, I think so, yeah. Because the good thing is about the business logic, having all the business logic in the same place, you can make sure that for us as like medtech, it has to be right. You know, the logic can't be wrong. You have to know that you took a dose. So like in that sense, the business logic, it's super important that we have it like solid. So you can't have bugs there. So for the sake of keeping business logic the same, yeah, I would. Maybe we do more things native than like UI and stuff. But yeah, in general, yes.
All right. Looks like our last question. Anonymous has had a few beers. How about old DP management systems? PHP admin, for example, what would you recommend?
I spent a fair amount of time in PHP my admin, but no, I like just use the console now, or I use our business intelligence app also has like you can just access the database and write queries in that straight away. So no. I would write real queries myself instead.
Fantastic. Thank you, Viktor. Let's give him a hand.